streams. Types of streams: byte streams, character streams. So there are two types of streams. First one, byte streams. Second one, character streams. Noted. Byte streams handle text, image, graphics, animation, audio, video, etc. Byte streams handle text, image, graphics, animation, audio, video, etc. Character streams handle text only. Byte streams handle text, image, graphics, animation, audio, video, etc. Character streams handle text only. So two types of streams are there: byte streams and character streams. Byte streams handle all types of data: text, image, graphics, animation, audio, video, everything handled. Character streams handle text only. In previous programs, read method, write methods, parameters, bytes or characters? Bytes. So those are byte streams. Okay. Previous all programs are whatever you studied, byte streams only. You observe. Suppose you have seen copy demo. This program you have seen. We copied data from one file to another file. I'll run again this program. Java C copy demo.java. Yes, I compiled. Java copy demo. Two files you have to pass: abc.txt, xyz.txt. I passed. Here we are getting exception. abc.txt file not there. File not found exception. Okay. On Java copy demo. Here demo.java, sample.java. If I write, what will happen? Demo.java content copied into sample.java. If I open sample.java, what will be there? Demo.java content will be there. Okay. Demo.java content. Like this. Now it is not only text file, images, audio, video also possible. For example, C drive. In C drive, you observe here flowers 2, flowers 3. 3 images are there. Okay, 3 images. See, it's an image. Flower 2 also, that is only. Flower 3 also, that is only. Now, I'll copy this image. You observe. Flower 4, I'll write. Flowers 4. Now, see. Java copy demo. Flower dot, that extension GFIF. GFIF. Flowers. Flowers is there? Flowers. Flowers 4. GFIF. Now, this image copied in this file. This file not there, you observe. 2, 3 is there. 4 not there. Now, if I run, now you can check. 4 created. See, flower 4. Just now created. Okay. Now, if I open, see, same image. So, whatever you studied that program, this program not only for text files, images also, audios also, videos also, everything. Because byte stream. This is a byte stream program. With this Java program, you can copy any type of data. All types of data can be copied. Okay. So byte streams handle text, image, graphics, animation, audio, video, everything. Character streams handle text only. Now, which are byte streams, which are character streams? Note. The hierarchy of byte stream classes. 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 See, object class is a super class. From this class, 2 classes derived. One class name is input stream. One more class name is output stream. From this class, some other classes derived. One class is file input stream. One more class is filter input stream. From this, data input stream. From this, object input stream. File output stream. Filter output stream. From this, 2 more classes, data output stream. One more print stream. Here object output stream. Ready, hierarchy? Superclass, subclass, purpose, hierarchy. Say, you studied input stream, you studied print stream, you studied file input stream, you studied file output stream, you studied. These four completed. Okay. Say, input stream class, nothing but console input stream. Print stream, nothing but console output stream. Accepting data from keyboard, this class. Displaying data on monitor, this class. Reading data from file, this class. Writing data to a file, this class. Whether it is studied? So, input stream completed, print stream completed, file input stream completed, file output stream completed. Now, still other classes are there. Say, we can use it one more pair, data input stream, data output stream. It is one more pair, object input stream, object output stream. But these three classes we cannot use, only super classes. Okay. Now, data input stream you can utilize, data output stream you can use, object input stream you can use, object output stream you can use. What's the difference? I'll explain. Say, accepting data from keyboard. Accepting data from keyboard, which class we use it? The scanner class, leave it. Scanner class, with this only scanner class came later, that is latest version, that is. Okay. First this one only. Here, which class we used? Input stream. System.in.read. System.in.read. Read method in input stream. Input stream reference in. In is the member of system class. So we written like this. System.in.read. This will be written. Okay. Read method in which class? Read method in which class? Input stream. Is it instance method or class method? Instance method. For calling this method, which class object required? Which class? System class required. That is which class method? Input stream class method only. Input stream object only required. That object referred by in. In is a member of which class? It is static or non-static? Static or non-static? That is the reason only class name. That is the reason only class name dot. Okay. Accepting data from keyboard. This class. Displaying data on monitor. Print stream. We written like this. System.out.println. Here. Println method which class? Print stream. Is it instance method or class method? Instance method. For calling this method, which class object required? Print stream. That out is a reference of print stream. Out is a member of system class. Is it static or non-static? That's what system dot. Okay. So accepting data from keyboard, this class. Displaying data on monitor, this class. Reading data from file, this class. Writing data to a file, this class. 4 classes you have seen. 4 classes you have seen. Okay. Now, data input stream, data output stream, 1 pair. Object input stream, object output stream, 1 more pair. That I'll explain. Next. Note. Data input stream and data output stream classes support all primitive data types. Input stream and data output string classes support all primitive data types and strings. Data object input stream. Object input stream. Object input stream. Object output string classes support objects. Object input stream and object output string classes support objects. See, data input string class and data output string classes support all primitive data types and strings. Object input stream and object output string classes support objects. But previous all programs you have seen byte array, only byte array. Now, first system.in.read only came. Later, data input string came. Later, scanner class came. But after getting scanner class, we are not using these all. But with the data input stream, data output stream also possible to access the data. At that time, conversion is not required. All primitive data type supports. See, is it over? Writing is over. See here, Java P, Java dot IO dot data input stream. If I type here, you observe, read boolean, read byte, read short, read char, read int, read long, read float, read double. Every data type separate method is there. Separate method. So you have seen we accepted data byte array format. After that, we converted into string. After that, we removed extra spaces. After that, we converted into integer. 4 lines only conversion. You already studied. Okay. Through system.in.read, we retrieve data byte array format. Byte array format to string. From that string, we removed extra spaces with a trim method. Later, we converted into integer. Okay. Like that, 4 methods, 4 lines you have seen. Only conversion. But now conversion is not required. Directly read int. You'll get an integer. Directly read int. Then you'll get an integer. Like this, introduced. Okay. But these two classes, now here all primitive data types possible. How many primitive types are there? 8. What are those? Byte, short, int, long, float, double, char, boolean. 8 data types. Every data type separate method. Read byte is there, read short is there, read int is there, read double is there, read float is there, like that. As well as strings also possible. Okay. But if you use these two classes, object at a time we can read. Object. It is one more type. So one class can have n number of instance variables. Those all comes under object. So at a time, 100 variables also you can read with this. Okay. Now, this program I'll teach. This program not required because already scanner class came. We are not using. Before going to this program, the hierarchy of character streams. 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 Now, you have seen byte streams hierarchy. Now, character streams hierarchy. Object class. From object class, 2 classes derived. Reader and writer. Reader, writer. From object class, one reader class, one writer class. Reader class, here buffered reader. Input stream reader. From this, file reader. Here writer class. buffered writer. Note buffered writer. Output stream writer. Here file writer. Here print writer. Are you listening class? Lost. Concentrating on mobile only, I think. Then attending class is waste. No use. Note on this hierarchy. Reader, writer. Buffered reader, buffered writer, input stream reader, output stream writer, file writer, print writer. See, you have seen like a input stream. Here, buffered reader we can use. Like a output stream, buffered writer, print writer we can use. Print stream. File input stream, file reader. File output stream, file writer. But objects not possible here. Character stream. Doesn't support. So, only difference, these streams you can use only for text. But byte streams, text, image, graphics, animation, audio, video, everything. All types of data can be used. But here only text. Only text. See, these programs also same, no change. Only character array will be there, strings will be there. Other types will not be there if you use. And also, whether it is byte stream or character stream, it is very easy to identify. Here, all class names you observe: reader, 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 reader. Here, writer, 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 writer. If the class name ends with reader, writer, reader, writer, that is character stream. If the class name ends with stream, 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 that is byte stream. Even in advanced Java also, internet streams comes. At the time also you can identify. Suppose Soulet input stream, Soulet output stream. Byte stream or character stream? Byte streams. Okay. Print writer, JSP writer, character streams. Advanced Java also, other streams comes. But those streams also easily can identify. If the class name ends with reader or writer, that class is bytes, character stream. The class name ends with stream, 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 byte stream. That's it. Only difference here, all types are byte stream, all types of data possible. Character stream, only text. That's the difference. Okay. Now, as compared to these all, only this is important. Object input stream, object output stream, important. Object input stream, object output stream, these two important, I'll give. Next node, object stream. One is object input stream. One more, object output stream. It is used to read an object from file. Object output stream. It is used to write an object to a file. Object input stream. It is used to read an object from file. Object output stream. It is used to write object to a file. Online students, voice is not clear. Voice is clear or not clear? Okay. Object input stream. It is used to read an object from file. Object output stream. It is used to write an object to a file. It is used to read an object from file. It is used to write object to a file. Object at a time if you want to read object input stream, at a time if you want to write object output stream. See, I'll give a methods, constructors methods, how to use, I'll explain. Is it over? See, Java P, java.io.object input stream. Methods I'll give. In this class, constructor method. Yeah, just package name I'll remove. Ready, so this all. See here, read object method. See method name only read object. What it will do? It will read the object. Okay. For calling this method, object required for this class. For creating object, this constructor required. For closing purpose, close. Is it over? So it is object input string class constructor and methods. Now, if you want to read object from file, this method you have to call. For calling this method, this class object required. For creating object, this constructor required. Okay. For closing purpose, close required. Is it over? Now, object output stream. Constructor method. Note. Now, task I'll explain. I'll ask questions. You have to give answer. With your answers, I'll write the program. Okay. Say write object. You can write object. For calling this method, this object required. For creating object, this constructor required. For closing, close required. Okay. Now, task I'll give you. Methods I given. I'll ask question, give answer. With your answers, I'll write. Okay. First, task related diagrams I'll give. Is it out? Same. Here, one object I'll create. Suppose employee number and salary. employee number and salary. Okay. Suppose for example, employee number 101, salary 5,000, like this. Okay. It's an object. It's an employee object. This object referred by E1, one reference. This object, it is going to be stored in RAM. Okay. This object data I want to write to a file. File name emp.txt. Okay. Employee number, salary. Object input stream required or object output stream required? What we required? Object output stream required. OS. Write this one. First I'll create object. That is, I'll write to a file. Writing purpose, object output stream required. Now see, we have to create object. That object contains data. That object referred by reference. This is in a RAM. This data I want to write to a file. This is on file. For writing this one, compulsory object output stream only required. Okay. With file output stream, if you want to write, again, this is separate you have to write. Employee number one's salary second. But every field one time you have to write. But here directly object at a time you can write. That is. You have seen already how to write data to a file with file output stream. But the byte format only possible. For object not possible. Okay. Then employee number you can write, salary separate you can write. Like that possible. But now object can have 100 fields also. At a time we can write. Okay. Now, after this, what I want is that file I'll open. That file I'll open. Okay. That file I'll open. I'll read. Now, emp.txt. Here, employee number, salary, I want to read. Then again object memory you have to allocate. EMP number, salary. That is, I'll read from file. In the same program, I'll show you both. It is RAM. Now, this data I want to read. How to read? Object input stream. This data I want to display on monitor. What we record? Console output stream. Now, write this one. That is, this is in a same program I'll write. Is it over? Here. Reading data from file and displaying data on monitor. Okay. Now, that diagram, this diagram, both in a same program. I'll ask questions, give me answer. With your answers, I'll write. Suppose file, new, Java. No. Suppose object stream demo. No. Here, first diagram. We have to create employee object. We have to create employee object. For creating object, first class required. Class required. What is the class name? EMP. In this class, how many variables required? 2 variables. Which type? Instance variable. So integer employee number. Suppose 101. Float. Salary 5,000. Okay, directly initialized. But today concept is not initialization, not consider writing object. But many objects, if you want, you have to use constructor. So one object only I'm using. Okay. So employee class I created here. employee E1 equal to new employee. It's over. Okay. Say class object stream demo loaded, main method called, either object created, then memory allocated to instance variables. Okay. That object referred by E1. Creating object in a RAM is completed. Creating an object in a RAM is completed. Okay. Creating an object in a RAM is completed. This object I want to write to a file. This object I want to write to a file. Which file? emp.txt. That file you have to open for reading or writing. You have to open a file for writing. If you want to open a file for writing, which class required? Which class? File output string class. That is we have to write. You already have seen file output stream. What we have to write? File output stream FOS equal to new file output stream. Here emp.txt. Okay. Now this file is open for reading. Writing. This file is open for writing. Already some data is there. What will happen? Overridden. Data erased. Overridden. If that file not there, it will be created. While creating, if any problem occurred, file not found exception occurs. How to handle? Try catch blocks. So try catch. Can I write exception? Yes, it will handle all the exceptions. System.err.println e. Okay. Now, file output string class in which package? IO package. Okay, that is required. Now, you observe employee class object created. Then memory allocated to instance variables. That object referred by E1. File output stream. Like this file is open for writing. This file is open for writing. That is okay. Now we have to write this object data to this file. This object data we have to write to this file. If you write with file output stream, binary format only possible. That's what we required object output stream. Now, in an object output stream, one method is there. Which method? See, write object. Write object. That method instance method or class method? Instance method. So, which class object required to call? Object. We have to create object. What we have to write? Object output stream. OOS equal to new object output stream. How many parameters are there? One parameter. What is a parameter? Output stream. Output stream. But I want to pass file output stream. Actually, what it takes parameter? Output stream. Output stream. Actual parameter is output stream. What I passed? File output stream. Open the hierarchy. Hierarchy given. In that hierarchy, you see which is superclass, which is subclass. Output stream is superclass. File output stream is subclass object reference assigned to superclass. That concept is called upcasting. That is upcasting. Okay. Now, this constructor parameter. What is a parameter? Output stream. But what I passed? File output stream. Which is superclass, which is subclass? Output stream is superclass. File output stream is subclass. File output stream reference assigned to output stream. So it is called upcasting. See, you already studied output stream, here file output stream. This is you studied. It is superclass, it is subclass. Now, this is upcasting. So I passed file output stream, but actually it takes output stream. Subclass reference assigned to superclass. It is called upcasting. So it is valid, no? Valid. Now, with this reference, can I call write object method? Yes. What we have to write? What is the return type of write object? Void. It doesn't return. Then how to call? OOS dot write object. How many parameters are there? One parameter. Which type? Object type. In the place of object, I am passing E1. Valid or not valid? Actual parameter is object class. But what I passed? What I passed? Employee class. Is it valid? How it is valid? Object class is a superclass. Employee class is a subclass. But where is extends object? Implicitly extends object. You already studied. In Java, every class directly or indirectly derived from object class. So here class EMP extends object. Okay. See, whatever you studied, these many classes required. No? All whatever you studied, all required. See, those who remembered, for them easy appears. Otherwise, difficult appears. Suppose you forgot extends object, you forgot upcasting. Is it possible? No. It appears like an English movie. Okay. And if you are irregular, it appears like a French also, Japanese also, Chinese also. That type appears. If you are irregular. If you are very regular, all points, if you remember, it appears like a Telugu movie. Otherwise, it appears like other language. That's it. Because that's what many times I told, up to exception handling, put efforts, work hard, put efforts, work hard. Many times I told, no. Not only now, Advanced Java also, Spring also, Hibernate everywhere. This is only required. Line by line, word by word, up to exception handling concept only. That's it. Now, here, what is a write object method? Write object method actual parameter is object. Here, I passed E1. E1 is a reference of employee. But actually what it takes? Object. But what I passed? Employee. Which is superclass, which is subclass? Object is superclass. Employee is subclass. Here, but where is extends object? Implicitly extends object. It is also upcasting. Valid. Here upcasting, here upcasting. Valid. Okay. Now, object return to a file. Now, suppose while creating this file, if exception occurred, then control jumps to catch block. Which exception throws? File not found exception. Will it handle file not found exception? Yes. How it will handle? Exception is superclass. File not found exception is here also upcasting. Here also upcasting. See, in a one program only 3 times upcasting. Here it will throw file not found exception. That is handled here because it is superclass reference. That is subclass object. Subclass object assigned to superclass reference. That concept is called upcasting. So it is valid. That's what it will handle. Now, this stream we have to close. This stream we have to close. For closing, actually, which block you have to write? Final block. Otherwise, one more concept is there. Try with resource. Later you can attach. Already learned. Present, what I'll do is this one only I'll write. Later you can attach. Now, year. Up to year, first part is over. OS demo. Class loaded. Main method called. Try block executed. In this line, object created. Then memory allocated to instance variables. That object referred by E1. Then emp.txt file is open for writing. After that, object output string created. With that object returned to a file. Both are closed. File save. If I compile, what will happen? See. Java C OS demo .java. Program successfully compiled. Program successfully compiled. Okay. Now, Java OS demo. See what we did. You observe once again. OS demo class loaded. Main method called. Try block executed. Object created. Then memory allocated to instance variables. File is open for writing. Object output stream object created. With that object returned to a file. Both are closed. If I run this program, object data should be returned to a file. That is our task. If I run this program, whatever I written 101.5000, it should be stored in a emp.txt file. But what will be happen? Just observe. We are getting one error. Java.io.not serializable exception. This concept is related to serialization. What is serializable? What is serialization required? See, but this error we didn't get yesterday. Yesterday we returned data. Day before yesterday we returned data to a file. We copied data, no? We copied data in a file. Already one program is there, copy demo. But we didn't get error. But we are getting this error. Yesterday different, today different. What difference you observe? It is a stream. First, what is stream? Flow of data from source to destination. It is a stream. It is source. It is destination. Okay. It is a stream. It is a source. It is a destination. Yesterday, what we written is byte array. In the right method, what we written? Byte array. Okay. Yesterday we written byte array. Today what we are writing is object. It takes object in the right method. Yesterday object. You observe yesterday byte array, today object. Yesterday right method. Yesterday or day before yesterday. Day before yesterday, copy demo program you have seen. In that program, right method takes byte array. This is byte array. Today program, right object method takes object. So yesterday different, today different. Yesterday I sent byte array. When I send byte array, this byte array transferred. This byte array transferred. It is successfully executed. Okay. Today I tried to write object, but we got an error. We got an error. Not serializable exception. Okay. What is serialization? I'll explain. Yesterday byte array we written, that is returned to a file. But today I'm writing object not returned to a file. We got an error. For example, general example you get a clarity. Assume this is like a pipe. Okay. Assume this is like a pipe. Now, assume this is like a pipe. Assume this is like a water. Can we send water through pipe? Yes. Okay. It is pipe. It is water. Water we are sending through pipe. It is possible. Okay. Assume it is pipe. It is ice. Can we send ice through pipe? No. If you want to send ice through pipe, what we have to do? We have to make it water. Then you can transfer. Again, if you want ice, reverse possible. But if you want to transfer one place to another place through pipe, not possible. White array like a water, object like a ice. Object, what we have to do? We have to convert into that concept is called serialization. Got it? Now, first you write that one. Serialization heading. Serialization. Note the process of converting an object into a series of bits. The process of converting an object into a series of bits is called as serialization. The process of converting an object into a series of bits is called as serialization. In Java, object must be serializable to do the following operations. In Java, object must be serializable to do the following operations. First one, writing an object to a file. Next, reading an object from file. Next, writing an object to a network. Next, reading an object from network. In Java, object must be serializable to do the following operations. First one, writing an object to a file. Second one, reading an object from file. Third one, writing an object to a network. Fourth one, reading an object from network. In these four situations, object must be serializable. So, converting object into bits format is called serialization. But if you want to do serializable object, how to do? I'll explain. But it's compulsory if you want to perform these operations. Now, in our program, this operation I performed. Writing object to a file. Even for reading also required. Sending in network also required. Receiving from network also required. So further, objects, if you want to send client to server, server to client, object should be converted into bits. Okay. So these all required, these all operations, serialization compulsory. But how to make object as a serializable object? We are getting not serializable. How to make object as a serializable object? Note on. Class must implements java.io.serializable interface. Class must implements java.io.serializable interface to make serializable object. Class must implement java.io.serializable interface to make serializable object. Class must implement java.io.serializable interface to make serializable object. So just we need to write implement serializable. We need to write implement serializable. Class must implement java.io.serializable interface to make serializable object. So what we have to do here? Implements serializable. Now it is interface. It is interface. What is interface? It is a collection of public static final variables and public abstract methods. Now it is interface. It can have only public static final variables, public abstract methods. You already studied. Whenever interface is inherited, then what we have to do? Whenever interface is inherited, then what we have to do? All methods must be overridden or subclass must be declared with abstract keyword. Otherwise, compile time error occurs. But in this interface, what are the methods are there? What are the variables are there? How to see? Java P, java.io.serializable. Here, open brace, close brace. Any methods are there? No method to override. It is empty interface. It is empty interface. It is called a marker interface, tag interface, empty interface. These are special interfaces. Note java.io.serializable interface is called as marker interface, comma tag interface or empty interface because no members in this interface. Java.io.serializable interface is called as marker interface, tag interface or empty interface because no members in this interface. Because no members in this interface. So no need to there is no method to override. There is no method to override. Okay. Java.io.serializable interface is called as marker interface, comma tag interface or empty interface. So few people they are calling marker interface, few people they are calling tag. That's what all names I given. Okay. Empty. There is no member. Marker. We are attaching like we are marking. We are attaching like a tag. That's what different type they are calling. Marker interface, tag interface or empty interface. All are having same name. Okay. Now I written implement serializable, but there is no method to override. It's empty. Now if I compile, if I run, see it is executed. It is written to a file. But empty interface, how it is working? It is empty, no? So myself, I'll create one empty interface, interface test, open brace, close brace. I'll attach. Will it work? So myself, I'll create one empty interface test. That is I'll implement. Will it work? No. But how it works? Interface is related to which object-oriented principle? Interface is which object-oriented principle? Abstraction. What is abstraction? Providing necessary information and hiding. How to make object as serializable? They provided. How it is working? Not provided. That is only abstraction. That implementation already present inside the JVM. But what they given in JVM, not given to us. That is only abstraction. Providing necessary. You want to make it object as a serializable. Make it. How to make? They given. But how it is working? Not given. That is only abstraction. Providing necessary, hiding unnecessary. Okay. Now it's converted into bits and written. If I open emp.txt, see, can you understand? No, because bit format converted. That is object converted into bits. That's what you cannot understand. Again, if you read data from file, reverse, deserialization done. Bits converted to object, then works, appears. That is not completed tomorrow. Okay, we'll see continuation tomorrow.